we're going to do some more chain rule examples. This time doing a little more challenging problems and synthesizing a few of the techniques we've already learned. So the first one that we're going to look at is this x squared times the square root of 9 minus x squared. So this one's a little more challenging because this isn't really just a composition of functions. It's actually two functions multiplied together. So there's actually any number of ways to do this, but the way I would suggest doing it is the standard product rule way. So you would say, all right, by the product rule, this should be 2x, so the derivative of that multiplied by the original function plus x squared times the derivative of the square root of 9 minus x squared. Now the problem is we don't know what this derivative is yet because we would need to use the chain rule to get there. So we're going to use the chain rule. We just have to kind of set the stage first. So to do that, let's take a look at this function. So the inside, that most inside piece, is 9 minus x squared. So that's my g of x. And the outside piece, or sort of that leftover component, is the square root of something. So that's the square root of x. It's the square root of that void that's left over. Now, what we have to do next is find f prime of x. Now, it's probably easier to write that as x to the 1/2, so that we can say f prime is 1/2 x to the negative 1/2. There's a lot that's wrong with that. So we're going to say that. So that's going to be 1 over 2 square root of x. All right, next we need to plug in g of x here. So we're going to say, Mistake City. F prime at g of x is 1 over 2 square root 9 minus x squared. Okay. Then we have to find g prime of x. So to find g prime of x, that's going to be negative 2x, right? Because that's 0. Bring down the power. And so then our final answer, or our result rather from this, not necessarily the final answer, when you multiply these two together, the 2's are going to cancel. That's going to leave you with a negative x over over square root of 9 minus x squared. So that's not really our answer though, right? That's just this piece for up here. So instead of this derivative, we can replace that with that piece. Now we could do a lot here. We could get like common denominators, and we could, we could simplify this a lot. There's nothing wrong with that, but for our purposes, let's just leave that alone, and that'll be our answer for now. So let's move on. The next one is a quotient rule. So we have to do low d high, well that's 9, minus high d low over low low, so we have to square that, but that just gives us this. But we have a problem. We need to find this derivative. We don't know what that derivative is. So we have to set up a chain rule. So what's the most inside piece? Well, that's going to be that x squared plus 6. What's our outside piece? Well, what's left over? If I sort of absorb that into a single term, if I squish that down to a single term, it looks like the square root of x. And luckily, just like up here, we know f prime of x is 1/2, or we'll just write 1 over 2 root x. We've already done the work there. And so f prime at g is 1 over 2 square root of x squared plus 6. And so then we'd find g prime, which is 2x. And then our answer multiplying these two together would be x over x squared plus 6, or square root of x squared plus 6. So we could go ahead and just plug that in. So our answer here replaces that derivative. Again, that's a little more complicated than it probably needs to be. What I would do is I would actually multiply top and bottom by square root of x squared plus 6, so that'll cause that to cancel. This will actually square out, so you'll end up with, if you do it that way, you end up with, it looks like 54 over x squared plus 6 to the 3/2, which is a much cleaner answer. So that's probably what you should do. It's also important to note that this could be rewritten, if you wanted to, as 9x times x squared plus 6 to the negative 1/2. And why is that important? Well, that's important because then you could do it with a product rule, and maybe you prefer doing that instead of using quotient rule. So this thing here, what I have is I have a quotient, but that quotient's actually inside of something squared. Now there's two ways to do this. The first way is just to rewrite this. So really that's not equals, that's the derivative equals. You know, that's that derivative equals. It's not really an equal. So you could just do this. You could just say, well, that's t to the 6th over t to the 8th plus 3 squared. And so then you could do a quotient rule, but you'd have to use the chain rule for this piece. Or we could write it like this. We could say, all right, this whole thing, this whole shebanger is my inside. So I'm going to say that my g of t is t cubed over t to the 8th plus 3. I'm going to say that my f of t is t squared, because it's that whole glob squared. So then I'm going to say f prime of t is 2t. So f prime at g is 2 t cubed t to the 8th plus 3. Like that, like so. Now I have to find g prime of t. So that one's going to be a little trickier. To find g prime of t, I'm going to have to do a quotient rule. So that's low d high minus high d low all over low, low. Ooh. Big nasty here. So if I multiply this through, what I get is 2t to the 10th minus 9t squared all over t to the 8th plus 3 squared. So then my final answer is these two things multiplied together. So I have a t to the 8th plus 3 here and a t to the 8th plus 3 there. And I have a 2 here, so that's going to be, and a t cubed here, so that's going to be 4t t to the 13th minus 18t to the 5th all over t to the 8th plus 3 cubed. That's big honkin' nasty, isn't it? And that's kind of the way you want to do that. It's just follow the process. Start working with the quotient rule. Start working with the product rule. When you get stuck, use another rule. In this particular case, start working with the chain rule. When I got stuck, I used the quotient rule. So never stop. Always keep making progress. When you get stuck, break it down into a further piece and keep going.